Assalamualaikum and hello to everyone. Welcome to our project presentation. This project was developed as part of the BITG1233 computer programming course under the guidance of our lecturer Muhammad Nazrin bin Zaraini. So we are from group 5. Our project title is PC Metric Calculator and our team consists of Anis Shahanum binti Syazali, Nur Syafiqah Ashikin binti Hamzah, Nur Husna binti Ghazali, Khairul Amir bin Khairul Anwar and Narwin Rush anak lelaki Tambi Raja. I am Nur Husna binti Ghazali and I will be the first presenter. Let's start by discussing the problem statement that we aim to solve our project. Firstly, the definition of a matrix is a rectangular array of numbers, symbols or expressions that are arranged in rows and columns. Matrices are often used in scientific fields such as physics, computer graphics, probability theory, statistics, calculus, numerical analysis, and more. Metric calculator calculates the resultant matrix when certain arithmetic operations are applied to the two given matrices. In mathematics, a matrix is a grid function or a rectangular array in which the numbers are arranged in order, rows and columns. Metric calculator is a tool that helps to perform different metric operations such as metric addition, metric subtraction, and metric multiplication. A metric that has the same number of rows and columns is known as a square metric. The dimensions of a metric are usually represented as m times n. Here, m denotes the number of rows while n represents the number of columns in that metric. Thus, a 2 times 2 metric will have 2 rows and 2 columns. In addition to matrices, if 2 have the same number of rows and columns, then an addition can be performed. To add 2 matrices, the elements of each row and column of one matrix are added to the respective elements in the other matrix. The figure below shows the formula for the additional matrix. Here a formula for multiplication matrix. Multiplication of matrices is multiplying 2 matrices. The number of columns in the first matrix should be equal to the number of rows in the second matrix.
Program structure chart. This program structure chart represents the design and workflow of a metric calculator application. It breaks down the main functionalities into submodules to ensure clarity and modularity. Here is a detailed explanation of the structure. The main module metric calculator acts as the central hub for coordinating the different submodules. It connects input, display, calculation of metric, and output process. First, input module. This module is responsible for collecting user input for metrics. Under input, there is input metric A where users specify the number of rows and columns. Then, input metric B. Similar to metric A, users provide the dimension and elements for metric B. Second, display module. This module is responsible for showing the entered metric on the screen. Display metric A function as displays the content of metric A after input, while display metric B function as display the content of metric B after input. Third, calculation of metric module. This module performs mathematical operation on the matrix. Addition of metric A and metric B is where it adds the corresponding elements of the two matrices provided they have the same dimension. Next, multiplication of matrix A and matrix B. Function X performs matrix multiplication, which is valid if the number of columns in matrix A equals the number of rows in matrix B. And the last one is output module. This module generates the result of the metric operation. Matrix A and matrix B function as outputs the entered matrix as reference. Second, addition of matrix function as outputs the result of the addition operation. And the last one is multiplication of matrix function as output the result of the multiplication operation.
As we can see at here, the start box, which it meant to be the terminal box, the program begins to execute and pass through to the open file condition to verify whether the program which has programmed the file is failed or successful with if else condition. Let's say the file is detected by if condition, so the program or file will fail and also will end to end, which is the user and also the input it won't receive once if the file is failed. Okay, so next for the else condition, let's say if the file is perfectly success to use, then the else condition will notify us to continue for next step. So once it's successful, so the file is open, the program reads data from matrix data and it will pass through to display menu with multiple options for the user to choose. Once the options are chosen, uh, the process of the get user choice, as we can see at the box on bottom of the open file successfully. Okay, uh, so the selection from display menu will appear that whatever the program that has been chosen by the user. Okay, so based on the user's choice, the program determine which operation to perform from the menu option, um, whether want to perform addition, perform subtraction, perform multiplication, or and exit on the matrix data. So let's say if the selection has been done, so the program loops back to the menu and this allows the users to perform multiple operations until they choose to exit, and this is loop functionality. So loop is actually is a one fundamental on this flowchart, which is to user to give various of chances to select whatever they want to select as they task requested. Okay, so we can make an action for the multiple choice of chosen, okay, until we select the exit button. Okay, so next, on the closed matrix result, the program will finalize its operation with the results file, and it will ensure all the data is properly saved the file, and also it will be closed and will store at the particular uh, particular box. Okay, so and once all it has been done, so at the last moment, so the process is we will get to know whether the process is being completed or the decision uh, the that we made is approved or rejected. Okay, and then at the last terminal the program will end to its execution.
This is our program codes. I will explain about function prototypes. For the function prototypes, it declares the available functionalities in the program, making it easier for others to understand the program's design. First, void display menu. Function S displays a menu with option for the user to choose from. Second, void input metric, where it allows the user to input values for a metric along with its dimensions, rows and columns. Third, void print matrix. Print the metric to the console based on its dimension. Next, void add matrix, where it adds two matrices, matrix A and matrix B, and store the result in the result matrix. Then, void multiply matrix, where it multiplies two matrices, matrix A and matrix B, and store the product in the result matrix. And the last one is void print matrix to file, where it outputs the matrix into a file via of stream.
Next, I will present about function while. The program reads a file that contains the metric data. It arranges the numbers row by row, starting with row A and column A, followed by row B and column B, which is the number is 1 until 10. The program processes the data, and if there are no issues, it generates the result matrix successfully. However, if the user inputs invalid data, such as letters or any characters other than numbers, the program will display an error message stating error cannot open matrix results. That's because it cannot process the invalid input to produce a result.
So next, my name is Khairul Amir bin Khairul Anwar. Metric number B132310434, and I will explain about menu-driven program. So we're using char for character for choice, and do display menu, and it will output enter your choice, and we need to input our choice, which is number 1 until number 7. And we're using the switch function. So for case 1, if we input the number 1, it will appear for matrix A, and we need to input matrix A, how many the rows and how many the column for matrix A. Same as case 2, we need to input the matrix B, how many rows for matrix B and how many columns for matrix B. Next, for case 3, if we input the choice is number 3, okay, it will print or appear the matrix A. And then same as case 4, is if we input number 4, it will appear or output the matrix B. Okay, next for case 5, if rows A is not equal to rows B, or columns for matrix A is not equal to columns matrix B, it will appear error. Matrix must have the same dimension for addition. For else, that is if. For else, add matrices, see out the sum of matrix A and matrix B, and it will appear the result, the sum of addition matrix A and matrix B. So next, in case 6, if columns for matrix A is not equal to rows for matrix B, it will output the error or appear the error. Error cannot multiply matrices. The number of columns in matrix A must be equal to the number of the rows in matrix B. Okay, else, if the column matrix A is equal with the rows in matrix B, it will multiply the matrix A multiply with matrix B, and it will output the product of the matrix and print the result after multiplication of the matrix. So next, last, case 7. If we have done using this program or calculator, it will appear, thank you for using the matrix calculator. Or if we insert the wrong value, it will appear invalid choice. Please try again.
This is void display menu. As we can see at here, there are 7 types of C output, including of the declaration of matrix calculator menu. Okay, this is actually the void display menu function is responsible for displaying a menu for a matrix calculator program, and the C out statements is to print option for the users as they wanted as a result. Okay, and each option has a specific functionality in the program. So first of all, input matrix A and B is actually represent as to ask the input number for rows and columns for the matrices from the user. Okay, and then the display matrix and the display matrix B is actually the output after taking the input from the users about the matrix are to be printed, and it will be displayed or back to the screen. And the number 5C out is actually the adding matrices of A and B, and also the C out of 6 is a multiply matrix A and B, and the 7 is actually is the code which will be not executed because it was already called as written to 0. So this menu allows the users to interact with the program by selecting operation as they wish to perform whatever they needs. Okay, now I'm moving on. For the void input matrix, we need to insert or input our value for rows and columns for our matrix. Okay, output had shown to enter number of as input and also to enter the number of column input, as we define here by denoting the notation as I and also column as j. And furthermore, for the loops for rows, or I is initialized with the starting of the value of 0, which means I is equals to 0. And for column loop, or as we can say as j, is also initialized with the starting value of 0, or j equals to 0. So thus, according to the fundamental of C++, for the loop, as we see at row number row number 6, okay, the input value for rows is 3, and it will calculate plus 1 for 3 times, as we use plus I, which will started from 0. And same goes to the input value for column is 3, so it will also be calculated as plus 1 for 3 times, as we use plus j, which is started from 0. And the next last one is the void print matrix. This function will print and will show the matrix after we input the rows and columns for matrix A or matrix B based on our loop function at void input matrix. As above, we can see at the void input matrix.
The matrix addition function add two matrices, which is matrix A and matrix B. It takes the matrices, their dimension, rows and columns, and uses nested loops to some corresponding element. Next, the matrix multiplication function multiplies two matrices, which is matrix A and matrix B. It checks if the number of columns in matrix A equals the number of rows in matrix B before proceeding. Using three nested loops, it calculates the product based on matrix multiplication rules. Next, the matrix printing to file function writes a matrix contents to a text file. It takes a file object, which is output file, the matrix and its dimension, rows and columns. Nested loops iterate through the matrix, writing each element with a tab separator and a new line for each row. This function ensures efficient handling of matrix operation and provides flexibility for saving results to external files.
So next we move on input and output file. So we're using the ifstream and offstream function. So for ifstream function, we need to create the matrix data txt or notepad form to run the matrix calculator. If we not create the txt data or notepad for matrix data, it will see out or appear the error could not open matrix data txt. So next for offstream, if we have run the PC matrix calculator or finish using the PC matrix calculator, it will output the file matrix result txt in our file for C++ program. So for the input file, we can see here, this is mini project for BITG computer programming. This is our matrix data txt in notepad form that we create just now. And we can run the PC matrix calculator, and the matrix calculator menu will appear. Input matrix A, matrix B, display matrix A, and so on. And we can enter our choice to use the calculator. So next, this is output file. The output file will appear after we finish use the PC matrix calculator. Then it will save the matrix result in notepad or txt form in our C++ file.
So lastly, program sampling. So here is the result of input matrix A and B. Here we have 7 selection, which is input matrix A, input matrix B, display matrix A, display matrix B, add matrices A and B, multiply matrices A and B, and lastly exit. So for example, if we enter our choice 2, which is input matrix B, and then we enter the number of rows, number of column, which is 3. So here is the outcome. Next is the result of display matrix A and B. So same as the previous one, we have 7 selection. So in the provided example, the input here is a 3 times 3 matrix for matrix A with element entered systematically starting with
1, 2, 3 for the first row, 4, 5, 6 for the second row, and 7, 8, 9 for the third row. For the next example, if we enter 4 as our choice, which is display matrix B, the input is also 3 times 3 matrix 4 display matrix B, and starting with 1, 2, 3 for the first row, 4, 5, 6 for the second row, and lastly 7, 8, 9 for the third row. Lastly, the result of sum multiply of matrices A and B. So in the provided example, if we entered 5 as our choice, which is add matrices A and B, the outcome will starting with 2, 4, 6 for the first row, 8, 10, 12 for the second row, 14, 16, and 18 for the third row. Next, if we entered 6 as our choice, which is multiply matrices A and B, the outcome will starting with 30, 36, and 42 for the first row, 66, 81, and 96 for the second row, 102, 126, and 150 for the third row. And lastly, if we entered 7 as our choice, which is AZ, it will show us thank you for using the matrix calculator. That's all from our group. Thank you.